Hello everyone, myself Raghu S, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So, in this session we will discuss Module 4, that is Measurement, Measurement System, Intermediate, Modifying and Terminating Devices. Okay, the contents are measurement, measuring instrument, significance of measurement, requirements of measurement and methods of measurement. First let us discuss what you mean by measurement. So this diagram, this block diagram shows the process of measurement. Measurement is a process of comparison of unknown physical quantity with the known physical quantity. So measurement is a process of comparison of unknown physical quantity, the quantity to be measured with the known physical quantity. The unknown physical quantity is called as measurand, the quantity to be measured. The known physical quantity is called as standard. Okay, here the comparison is made between known and unknown physical quantity is called as measurement. Measuring instrument means a device or instrument used for measurement process is called as measuring instrument. Say example, dial indicator, so it is a measuring instrument. Vernier caliper, it is a measuring instrument. Micrometer, it is a measuring instrument. Autocollimeter, so it is a measuring instrument. Next, this diagram shows the example for measurement. Okay, here my objective is to measure the length of this component. So for any measurement process we need a standard. So without standard we cannot able to do any measurement process. Therefore for any measurement process we need a standard. Okay, here this is the component, so whose length to be measured. Okay, here for this purpose I have taken steel rule. Here a comparison is made between unknown physical quantity with the known physical quantity. So this process is called as measurement. Next, significance of measurement. Significance or applications or purpose of measurement. So why measurement is required? Measurement is mainly required to determine the dimensions of a component. Next, measurements are commonly used in control systems. So in order to monitor the various control systems. Measurements are used in research and development activities. So in this, okay, here we know that every research involves some experiments. So experiments are based on some measurements. Therefore measurements are used in R&D activities. Then measurement used in commerce in order to estimate the cost of the products. Next, measurement. So measurement is used to evaluate the performance of plant or process. Say example, in thermal power plant, temperature and pressure can be monitored by measurement. These are all some significance of measurement. So measurement is mainly used to determine the dimensions of component. Next, measurement is used in R&D activities. So measurement is used in control system. So measurement is used in commerce to estimate the cost of the product. Measurement is used to evaluate the performance of plants or process. So these are all some significance of measurements. Next, move on to requirements of measurement. See, for the measurement to be accurate, okay, here the two requirements, here we should meet two requirements. The standard used for comparison must be accurately defined and should be universally accepted. The first requirement, the standard used for comparison must be accurately defined and universally accepted. Second one, the operator used and the method adopted for the measurement must be provable. So these two are the requirements of measurement. Next, move on to the methods of measurement. there are various methods of measurement like direct method, indirect method, deflection method, null method, coincide method, comparison method. So now here we will discuss the direct method of measurement and indirect method of measurement. So this diagram shows the direct method of measurement. So as the name indicates, in the direct method of measurement, the unknown physical quantity is directly compared with the known physical quantity. Okay, here there is a direct comparison. There is a direct comparison between unknown physical quantity and known physical quantity. But the direct method of comparison is not always accurate. Not always accurate. Okay, here, so this is the example for direct method of measurement. Okay, here the length of the component is measured by using steel scale. There is a direct comparison. So this method is commonly used to measure mass and length. Second one, indirect method of measurement. Some physical quantities which cannot be measured directly. Say example, strain. Strain I cannot able to measure directly. Okay, here some of the quantities which cannot be measured directly. So for those quantities which can be measured by using indirect method. So indirect method is accurate and high sensitive compared to direct method of measurement. Okay, here this block diagram shows the indirect method of measurement. Okay, here consider an example for measurement of temperature. Temperature is measured by using thermocouple. Thermocouple, it is a measuring instrument which measures the temperature in terms of voltage. Thermocouple detects the small change in temperature and the thermocouple converts the change in temperature into voltage. Now, okay, here we have one more device, amplifier. This amplifier converts the small voltage into larger voltage. So this modified or amplified voltage is displayed on the display device. So finally the temperature is converted into voltage. So okay, here this is the indirect method of measurement. Okay, here I am measuring the temperature in terms of voltage. So this method is commonly used to measure force, temperature, strain, pressure, torque, etc. It is accurate and high sensitive compared to direct method of measurement. So in this method, so okay, here, so we are using some chain of devices called as measurement system. So with the help of chain of devices, so okay, here we are going to measure the physical quantity. So this physical quantity is converted into other measurable form. So on one more example, measurement of force using load cell. So load cell is a device which measures the force in terms of voltage. So that is also one more example for indirect method of measurement. Now let us discuss the difference between direct method and indirect method. So what are all the differences between direct and indirect method? The first difference, in case of direct method, the unknown physical quantity is directly compared with the known physical quantity, direct method. In case of indirect method, the unknown physical quantity is indirectly compared with the standard. Direct method, it is less accurate. Indirect method, it is more accurate. So direct method, it is less sensitive and indirect method is more sensitive. So direct method is commonly used to measure mass and length, whereas indirect method is used to measure force, torque, pressure, temperature, strain, etc. And example for direct method, measurement of length of component using steel scale. Indirect method example, measurement of temperature using thermocouple, measurement of force using load cell, measurement of strain using strain gauges. So these are all the example for indirect method of measurement. So far we have discussed the definition of measurement. So measurement nothing but process of comparison of unknown physical quantity with the known physical quantity, that is called as measurement. Measuring instrument means the device which is used for measurement process is called as measuring instrument. So we have discussed the significance of measurement. Next, we have discussed the requirements of measurement. And then, so we have discussed the methods of measurements. We have two methods, direct method and indirect method. And also we have discussed the differences between direct method and indirect method. So next we will discuss the generalized measurement system and example for generalized measurement system. So next let us discuss the elements of generalized measurement system. The block diagram shows the elements of generalized measurement system. So the elements are, we have three elements or three stages: detector transducer stage, intermediate modifying stage or signal conditioning stage, and last one, terminating stage. You can take any measurement system, so these three elements are common. So that's why it's called as generalized measurement system. When you take any measurement system, okay, here these three elements should be there in order to measure a physical quantity. Now let us discuss the working of generalized measurement system. Now, okay, here this is the first stage, detector transducer stage. The function of this stage is to detect the physical quantity to be measured. Okay, here this is the physical quantity to be measured. So it may be force, temperature, pressure, torque, strain, etc. Now the physical quantity to be measured is detected by a detector or sensor. Okay, here this first stage consists of detector and transducer. The detector detects the physical quantity to be measured. Next, the detected physical quantity is converted into analogous form by using transducer. Transducer is a device which converts the detected physical quantity into analogous signal. So we have various transducers like mechanical transducer, electrical and electronic transducers. So this is the function of first stage. The first stage consists of detector and transducer. The detector which detects the physical quantity to be measured. Then after, transducer converts the physical quantity into analogous output, a continuous signal. Next, move on to second stage, intermediate modifying stage. This intermediate modifying stage, it is also called as signal conditioning stage. The function of this stage is to manipulate the signal obtained from the first stage. It performs three functions. So first one, signal amplification. Next, signal filtering. And last one, signal conversion. The intermediate modifying stage, it performs three functions: signal amplification, signal filtering and signal conversion. So what do you mean by amplification? Amplification means increasing the amplitude of the signal. Okay, here we are using amplifiers. The function of amplifiers is to convert the small signal into large signal. That means amplifier increases the amplitude of the signal. Next, signal filtering. Signal filtering means removal of unwanted signals and variations. Finally, signal conversion. Signal conversion involves conversion of analogous form or analogous signal into digital form. So this is done by using data loggers. Signal conversion, it is done by using data loggers. So these are the functions of intermediate modifying stage. Next, the last one is terminating stage. Terminating stage, or it is also called as display stage. The function of this stage is to provide the data in readable form to the human being. It presents the data in three forms, like pointer movement on scale, or in the form of graphs, or in the form of digital format. So these are all the functions of three elements. So in the detector transducer stage, it detects the physical quantity to be measured and converts into analogous output. This intermediate modifying stage, it modifies the signal obtained from the first stage. So finally, the terminating stage, it provides the data obtained from the second stage, so in readable form to the human being. Now let us discuss the example for generalized measurement system. Okay, here as you are seeing in the diagram, so okay, here this is called as Bourdon tube pressure gauge. So Bourdon tube pressure gauge, so it is used to measure the pressure. So this is the example for generalized measurement system. Okay, here we are seeing C tube. That C tube acts as, that C tube is called as Bourdon tube, and that Bourdon tube, so it acts as detector transducer element. The function of Bourdon tube, the function of C tube, as you are seeing in the diagram, it detects the pressure to be measured and converts the pressure into small mechanical displacement. Next, second one, as you are seeing in the diagram, okay, here we are seeing mechanical linkages and gears. Mechanical linkages and gears form intermediate modifying elements. So those mechanical links and gears amplifies the displacement obtained from the first stage. Next, as you are seeing in the diagram, okay, here we have pointer and scale arrangement. That pointer and scale arrangement, it forms the terminating stage. So it forms the terminating stage. So it displays the pressure. So in the form of pointer and scale arrangement. Now let us discuss the function. Now, okay, here the Bourdon tube pressure gauge, the pressure to be measured is applied to the C tube. So when we apply pressure to the Bourdon tube, the tube tends to straighten out. And hence we are observing a small mechanical displacement at the free end. That small mechanical displacement is amplified, so by using mechanical links and gears. The amplified mechanical displacement is displayed, so using pointer and scale arrangement. Therefore, in the diagram Bourdon tube pressure gauge, the Bourdon tube acts as detector transducer element. The mechanical links and gears acts as intermediate modifying elements, and the pointer and scale acts as terminating elements. So this is the example for generalized measurement system. So for any generalized measurement system, so we are observing the three elements: detector transducer elements, intermediate modifying elements, and terminating elements. The function of detector transducer stage or elements is to detect the physical quantity to be measured and convert that into analogous form. Intermediate modifying stage or signal conditioning stage, so it modifies the signal obtained from the first stage. Modification involves like amplification, filtering, or signal conversion. So finally the modified signal is displayed. So it displayed or presented in readable form to the human being. So this is all about the generalized measurement system. So next we will discuss some static and dynamic characteristics of measuring instruments. The performance of measuring instrument is described by using characteristics. Okay, here mainly we have two characteristics: static characteristics and dynamic characteristics. Static characteristics are considered when the measuring instrument is used to measure the physical quantities which are not varying with time. Dynamic characteristics are considered when the measuring instrument used to measure the physical quantities which are varying with time. Okay, here these are all some few static characteristics like accuracy, precision, calibration, sensitivity, linearity, threshold, hysteresis, and loading effect. So whereas dynamic characteristics are system response, amplitude response, frequency response, and speed of response. So the performance of measuring instrument is described by using static and dynamic characteristics. So the static characteristics are considered when the measuring instrument is used to measure the physical quantities which are not varying with time. Whereas the dynamic characteristics are considered when the measuring instrument is used to measure the physical quantities which are varying with time. Now let us discuss one by one. So accuracy, precision, calibration, sensitivity, linearity, threshold, hysteresis and loading effect. Now before discussing the accuracy and precision, first we should know what you mean by true value and measured value. So before discussing about true value and measured value, first we should know about the uncertainty in measurement. You can take any measurement process, so it is too difficult to measure the actual value. We can estimate the value, but we cannot able to measure the absolute value. Say example, the length of the component. So the length of the component which is measured, so it is about 500 mm. It is about 500 mm, but it is not exactly 500 mm. This value is measured by using measuring instrument, and this is called as measured value. The actual value, so it may be 500.000001 mm. This is the actual value. So it cannot be measured by using measuring instrument. So this is called as true value. Therefore, we should know the difference between measured value and true value. So average value means the value given by measuring instrument. So true value, it cannot be measured. Then how do we take the true value? So usually the average of the measured value, it can be taken as true value. The difference between measured value and true value is equal to error. So difference between true value and measured value, so it is called as error. Now let us discuss the definition of accuracy. So now let us discuss some few static characteristics of measuring instruments. The first one, accuracy. So accuracy indicates how measured values are closer to the true value. If the measured values are closer to the true value, then it is more accurate. If the measured values are not closer to the true value, then it indicates, so it is poor accuracy. Okay, here in this diagram, this arrow mark, so this is the true value and this is the actual value, and these are all measured values. Okay, here all four measured values are closer to the true value. So accuracy indicates the degree of closeness of measured value with the true value. Therefore accuracy, okay, here this is the good accuracy, because okay, here we have four measured values: measured value 1, measured value 2, measured value 3 and measured value 4. All four measured values are closer to the true value. Therefore it is good accuracy. So in this diagram, this is the true value and these four are measured values. Okay, here measured values are not closer to the true value. Therefore it is poor accuracy. Therefore accuracy is defined as the degree of closeness of measured value with the true value. If the measured values are closer to the true value, it is good accuracy. If the measured values are not closer to the true value, it is poor accuracy. The second one, precision. Precision indicates the degree of closeness of measured values. It indicates the repeatability of measuring instrument. So if the instrument is precise, so it will give the same output for the same input. If the input is, so if the instrument is not precise, so it will give the different readings for the same output. Okay, here this is the good precision. Okay, here we have some 5 measured values. So measured value 1, measured value 2, measured value 3, measured value 4 and measured 5. Observe here, all 5 measured values are closer to each other. I am not talking about with respect to true value, just I am talking about only the measured values. If the measured values are closer to each other, then it is good precision. If the measured values are not closer to each other, then it is poor precision. Okay, here measured values are not closer to each other, so it is poor precision. If the measured values are closer to each other, then it is good precision. If the measured values are closer to the true value, then it is good accuracy, remember. So this is the difference between accuracy and precision. Now, so let us understand one more example. Okay, here so plus mark indicates the true value. Now The 4 dots indicates the measured values. Now let us identify the good accuracy and good precision and poor accuracy and poor precision. This plus symbol indicates the true value and the 4 dots indicates the measured values. Observe in the first diagram. See, all 4 dots means all 4 measured values are closer to the true value. Therefore, it is good precision, good accuracy because 4 measured values are closer to the true value. At the same time, all 4 dots are closer to each other. Therefore, it is good precision and good accuracy. Second one, observe here, all 4 measured values are not closer to each other, and at the same time all 4 measured values are not closer to the true value. So, see here, all 4 measured values, 4 dots are not closer to the plus mark. Therefore, it is poor accuracy. At the same time, the 4 dots are not closer to each other. Therefore, it is poor accuracy and poor precision. Here, all 4 dots are closer to each other. Therefore, it is a good precision, but the 4 dots are not closer to the true value. Therefore, it is a good precision and poor accuracy. Good precision because all 4 dots are closer to each other, but poor accuracy because all 4 dots or 4 measurables are not closer to true value. So, this is about the accuracy and precision. Next, move on to calibration. What do you mean by calibration? So, calibration means the process of comparison of measuring instrument with the standard. So, in other words, so in calibration is done to check whether the instrument gives correct reading or not. So, calibration is done to check the accuracy of measuring instrument. So, calibration is done to check whether the instrument gives correct reading or not. In the calibration process, set of known inputs are applied to the measuring instruments and corresponding output values are noted down. Okay, here, so this is the measuring instrument. Okay, here I am applying some known inputs to the measuring instrument and corresponding output values are noted down. And a graph is plotted. So, a graph is plotted, input against output. And here we have got a curve, and this curve is called as calibration curve. So, calibration means comparison of measuring instrument with the standard to check the accuracy. So, okay, here as the instrument is used, so accuracy get decreased. So, therefore, in order to check the accuracy of measuring instrument, so we need to do the calibration. So, the next static characteristic, threshold. So, threshold means this is the input and this is the output. The minimum value of input below which there is no output. Okay, here up to this value, okay, here I am not getting any output. Up to this value. After this value, okay, here I am getting output. Therefore, this is the minimum value of input below which there is no output. This minimum value of input is called as threshold. So, example, some few pressure gauges, so will not respond till the pressure reached up to 1 kilopascal. So, that 1 kilopascal is called as threshold. So, up to that pressure, the pressure gauge will not respond. So, this is because of friction, to overcome friction. Therefore, so threshold means the minimum value of input below which there is no response, there is no output is called as threshold. Okay, here these are all static characteristics of measuring instruments. So, the next static characteristics are sensitivity. Sensitivity is defined as the ratio of change in output to the change in input. Okay, here it is denoted by K. So, when you draw calibration curve, okay, here the slope of the curve indicates the sensitivity. Okay, here the sensitivity nothing but change in output to the change in input. So, that is called as sensitivity. It is denoted by K. Next one, linearity. So, linearity means if a measuring instrument is said to be linear, if output is proportional to input, then the measuring instrument is said to be linear. Okay, here when the output is proportional to the input, we will get idealized straight line. So when the output is not proportional to the input, then we will get the curve. Therefore, linearity is defined as the maximum deviation between actual curve and idealized straight line is called as linearity. Next, the last one, hysteresis. So, consider a measuring instrument. So, suppose if we increase the input value from 0 to peak, then output also increases. Then if you draw a curve, input versus output, okay, here we will get the curve like this. So, this is called as increasing curve, curve 1. Next, if you conduct the experiment from peak value to 0 value, then so we are going to reduce the input value. So, therefore, the output also decreases. Therefore, we will get the curve 2. This is the decreasing curve. So, but actually the both increasing and decreasing curve should be coincided. But the non-coincidence of increasing curve and decreasing curve is called as hysteresis. The hysteresis reason friction, magnetic effect and thermal effect. So because of these three reasons, okay, here we are observing the non-coincidence of increasing curve. Means if you are conducting the experiment from 0 to peak value, we are going to get the increasing curve. If you conduct the experiment from peak value to 0 value, so okay, here we are going to get the decreasing curve. The non-coincidence of this increasing and decreasing curve is called as hysteresis. But ideally, both the curve should be coincided. But in actual case, so okay, here, so we are observing the non-coincidence of increasing curve and decreasing curve. So these are all about the static characteristics of measurement system.